Welcome back. Today, we are diving into the invisible plumbing that powers the entire cloud, Linux networking. When a site goes down, or a database connection times out, the problem is almost always in the network layer. If you can't debug a subnet or understand a firewall rule, you cannot build secure infrastructure. In the next 8 minutes, we are going to master the 15 concepts and tools that keep the internet running. First, let's look at the map. This is the OSI model. Now for exams, you memorize all 7 layers. But in Devops, we really care about 3. Layer 3 is the network layer. This is your IP address. Layer 4 is transport. This is TCP and UDP ports. And layer 7 is the application. This is HTTP or your actual data. When things break, we troubleshoot from the bottom up. Is the IP reachable? Is the port open? Is the app responding? In the cloud, you live and die by CIDR blocks, that slash number at the end of an IP. Look at the visual here. A/24 isn't just a random number. It defines the size of your network. It tells the router, this specific range of 256 addresses belongs to me. Understanding the difference between A32, which is one single computer, and A0, which is the entire internet, is critical when you are writing security rules in AWS or Azure. How does your server actually connect? We used to use ifconfig, but that tool is deprecated. The modern standard is the IP command. When you type ipaddr, you see your interfaces. ETH0 is usually your main door to the internet. But notice low, the loopback interface. This allows the server to talk to itself. If loopback is down, your local services will fail, even if you are connected to the internet. Think of an IP address as a street address for a building. A port is the specific room inside that building. You can't just knock on the front door. You have to know which room the service is in. Web traffic knocks on port 80 or 443. SSH uses port 22. If you launch a Docker container and can't reach it, 99% of the time, the door or the port is locked or mapped incorrectly. The most basic question in networking is the server there? We answer this with ping. It sends a tiny ICMP packet across the wire and waits for a localized echo. It tells you 2 things. Is the host up? And what is the latency? However, be warned. Many modern cloud firewalls block ICMP packets by default. So if a ping fails, the server might still be alive. It's just ignoring you. The most basic question in networking is the server there? We answer this with ping. It sends a tiny ICMP packet across the wire and waits for a localized echo. It tells you 2 things. Is the host up? And what is the latency? However, be warned. Many modern cloud firewalls block ICMP packets by default. So if a ping fails, the server might still be alive. It's just ignoring you. The most basic question in networking is the server there? We answer this with ping. It sends a tiny ICMP packet across the wire and waits for a localized echo. It tells you 2 things. Is the host up? And what is the latency? However, be warned. Many modern cloud firewalls block ICMP packets by default. So if a ping fails, the server might still be alive. It's just ignoring you. Since ping is often blocked, how do we really test connectivity? We knock on the specific door using Netcat or telnet. By running NCZV followed by the IP and port, we attempt a TCP handshake. If you get a connection succeeded message, the path is clear. If it hangs, a firewall is likely dropping your packet silently. This is the definitive test for connectivity. Sometimes the network is fine, but your application is asleep. You need to verify if your server is actually listening for connections. We use the command ss-tulpan or netstat. Look at the output. If you don't see your application listed with the state, listen, it doesn't matter if the firewall is open. Nobody is home to answer the door. Always check this locally on the server first. Computers don't speak English. They speak numbers. They don't know https://www.google.com/search?q equals google.com single quote semicolon. They know IP addresses. DNS is the phone book that translates the two. When your code says connection failed, it is often a DNS resolution issue. We use tools like NSLookup or the more powerful dig to ask the system, where does this name actually point to? If the phone book is wrong, you'll never reach the destination. As a DevOps engineer, you don't always have a web browser. curl is your browser. It allows you to make HTTP requests directly from the terminal. By adding the degv flag for verbose, you can see the invisible details, the SSL handshake, the response headers, and the status codes. This is how you debug API errors and verify that your load balancer is passing the right data. If your connection is slow or dropping, you need to know where the bottleneck is. Traceroute maps the journey of your packet as it hops from router to router across the internet. It shows you every stop along the way. If the connection times out at hop number 3, you know exactly which ISP or router is dropping your traffic, proving it's a network issue and not your server. Just because Amazon or Google allows traffic to your instance doesn't mean your server accepts it. Linux has its own built-in bouncer called IP tables, or the simpler interface UFW. A common mistake is opening a port in the Cloud Console but forgetting to open it on the server itself. Always check sudo UFW status to ensure you aren't accidentally locking yourself out. Here is a pro move called SSH tunneling. Sometimes you need to access a private database that has no public internet access. Instead of exposing it to the world, you can use an SSH tunnel to forward a local port on your laptop through a secure Bastion server and directly to that private database. It's like digging a secret, secure tunnel through the internet. So when things break, don't guess. Follow the workflow. Step 1. Can I ping it? Step 2. Does the name resolve with NS lookup? Step 3. Is the port open with Netcat? And finally, is the application rejecting me with curl? By isolating the problem to a specific layer, you stop guessing and start fixing.